Hello, in today's video we're going to be discussing quite a number of topics. We're going to first discuss this idea of mixtures and the two types of mixtures that chemists generally come in contact with. Then we'll move on to the three mass laws that we use and you'll be using for the rest of your semester. And then we'll finish with starting to talk about the first theory about atoms. And so we're going to cover three very different topics in this video, and we're going to move through it very quickly. However, tomorrow in class, we're going to work with a lot of problems about different mixtures, as well as using these mass laws and something known as mass percent. And then I just wanted to introduce the atom because in the next video, we're going to be talking extensively about it. So let's jump right in. Let's first start talking about the two types of mixtures that chemists generally come in contact with. The first one I want to consider is called a heterogeneous mixture. And this type of mixture has one or more visible boundary lines. So what's a boundary line? Well, let's think about a simple example. Let's take a glass of water and pour some oil in it. And if you've ever done this, you can go home and do this in your kitchen tonight. The water will be on the bottom of the glass and the oil will be floating on top of the water. And there's clearly a boundary condition between the oil and the water. So this would be called or considered a heterogeneous mixture. There's definitely two phases here, so we're going to be calling it heterogeneous. Another example of that would be, let's say, this picture of candy. What you can see here, there's all different types of candy that are easy to pick out. We could separate this out by physical means. We could go in visually and just pick out different candies and say, okay, this was this red type of candy, this was an orange type of candy, and we can separate that out just through visual process alone. So a heterogeneous mixture can be separated by physical means. Any type of physical means. This is filtration. We can use melting points. We can do things like that that are related to physical properties. So let's move on to the second type of mixture that chemists come in contact with. Those are called homogeneous mixtures. This is where there is no two-phase presence. So there's no boundary between the two phases. So let's see what this would look like. Let's take Kool-Aid. I'm assuming that all of you have drank Kool-Aid or made Kool-Aid at some point in your life. So this is clearly a mixture. We have water, we have sugar, and we have the little package of Kool-Aid that we put in to add the flavor. But once we add all of that together into a container, what happens is the water dissolves all of the solids, and there is no you can't tell if there are two different phases. There's no solid chunks of sugar floating around, or there shouldn't be at least. There's no the packet of flavor has been mixed all the way through. So you can't tell that this is composed of multiple types of components. And so this is considered a homogeneous mixture. Now, a homogeneous mixture, if it's a liquid form, is called a solution. And we're going to be calling those aqueous solutions from here on out. We'll be talking about aqueous solutions a little bit later on in later chapters. However, I wanted to show you what a homogeneous solution would look like, and Kool-Aid's a good example of that. So let's talk about some of the tools that we can use in laboratory to separate out mixtures. So the first one, there are 5 different separation techniques that I want to talk about. The first one is going to be considered a filtration. This is using any type of sieve such that when we pour in a mixture, only certain particles are allowed to move through the sieve. So this is based solely on the difference in particle size. Now all 5 of these are just separation techniques, but they're words that you should know. Every chemist knows these words, and every chemist should be able to use these words in a laboratory setting. So we'll be using a few of these in lab throughout the semester. So filtration, it's based on the particle size. Crystallization. Sometimes it's beneficial to dissolve out a salt. And we know table salt, if you pour it in water, it dissolves out and it becomes a solution. But if you heat up that liquid, you can actually crystallize that sodium chloride, which is table salt, back into its crystalline form. And so this, in a lot of occasions, makes the crystal more pure. This is a purification technique. So crystallization has its foundation in the difference in solubility. Now, what solubility means, some things will be able to be dissolved in water, and then if we add to that solution a new element, sometimes we can crash out a crystal out of that solution. So crystallization is a way of separating out different components in the solution. Distillation. You've all seen this in a movie at one point or another. This is where people who are making moonshine, they have all this glassware, and there's this nice flask, and it has a glassware that's connected like this. And as you heat up that flask, you get vapor, and then it condenses. And so this is the process of distillation, and we use this a lot in making alcohol. So distillation uses the difference in volatilities. So if you have a mixture of solutions, one of the solutions is going to boil quicker than the other one. And you generally use distillations when the boiling points are very, very different. So the one that boils faster, the one that has higher volatility, boils off quicker. And we can separate that out through this idea of distillation. Extraction. This is if we had a solid mixture and it's composed of different components, different elements and compounds. Some of them will be able to be dissolved in certain solvents, which is the liquid that we can add to this, and some of them won't. So what that would be is if we had a mineral, let's say we had quartz, and it was covered in table salt. We wanted to separate out the two mixtures. This is a heterogeneous mixture, but we want to be able to separate these two things out. Well, we know table salt dissolves in water while quartz doesn't. And so we could just pour water on this, and the table salt would go with the water, while the solid quartz crystal would remain solid quartz crystal. So extraction, this is difference in solubility. And then we have chromatography. This is also a difference in solubility. And what this is, you probably have seen this on CSI if you've ever watched CSI. They always talk about thin layer chromatography or a gas chromatograph, stuff like that. These all have utilize this idea of difference in solubility. So we can separate out the different components by using different solvents. So these are the 5 types of separation techniques that chemists come in contact with in laboratory all of the time.